Okay, this screencast picks up on the discriminant, and I know there has been a screencast on that already, but I'd just like to consolidate a few things perhaps that we looked at in class today. The discriminant, remember, just finds out for us the nature of the roots, so the value of the discriminant will give us a read as to the nature of the root. So if the discriminant is greater than 0, then there are two. If the discriminant is greater than 0, then there are two distinct roots. If the discriminant is less than 0, then there are no real roots. I suppose I should have real in there. And if the discriminant is equal to 0, then we have what's called two equal roots, or just one root. Okay, so they're the possibilities for the discriminant. Then we just go about usually solving equations and inequalities. So this is where I'm taking this screencast, is really towards the point at which we find the discriminant in terms of P or M or K or whatever it is, and we have to solve an inequality. That's all right if we're asked for two equal roots, as we are if I look at the exercises in question 3, because we're solving equations and we're used to that. But in question 2 and question 4 and 5, we're solving inequalities. Now, inequalities such as the one up here in 2a, shouldn't be any real issue with that, I don't think. Please let me know if there is, but that's linear inequalities. As long as you change the sign around when you divide by a negative number, that's fine. But when we get down to C here, we've got now a quadratic inequality, and this brings up another sort of challenge. Okay, so if we just have examine what I've done here, we get to the point in C where p squared minus 32 is greater than 0, because this here is the value of the discriminant. I forget, this is 2c. So then I'm looking for values of p that solve this inequality. So the best method, I think, for solving a quadratic inequality is to draw that quadratic. So what I've done now is I've just drawn the graph of p squared minus 32. There it is there. So this is p on my horizontal axis. This is p squared minus 32. It goes through minus 32 down here, you can see, and its intercepts, its x-intercepts, are at square root of 32 and minus the square root of 32. And so what they're the crucial points. So for p values greater than 4 root 2 or square root of 32, you can see that we get a positive reading for the value of this quadratic. And for less than square root of 32, we get a positive reading. But between minus 4 root 2 and 4 root 2, we get negative readings. Now we're solving greater than 0, so we're interested in, I've highlighted the areas that are greater than 0. So this is the part of the curve greater than 0, this is the part of the quadratic greater than 0. So these are the values of p that are greater than 0. So we write our solution like so. Okay, don't worry about this bit over here. I was working with Ricky on that one. I might just do one more, and that is, let's go down to 4c. Oh no, so it's 4c, it's 4b. And in 4b, we are asked to find the values of m such that the equation has no real roots. Okay, so I'll get my discriminant here to be 5m times 25m squared, that's b squared, minus 4a, so it's going to be minus 100. And I need it to be no real roots, so less than 0. So the way I go to solve this, I'm going to divide through by 25. I get m squared minus 4 is less than 0. Now, if this is an equation, it's really easy to solve. It's plus or minus 2, but it's not an equation, it's inequality. So as I said a moment ago, the best way of solving this, I reckon, is to draw the graph of m squared minus 4. Okay, so let's do that, and we'll just whip up a little set of axes here. M squared minus 4, well, that, you know what that does, it's just a translation 4 units down, isn't it? So we go through minus 4 there. Now, what is this? What are the x coordinates here, the roots here, because that's really important. It's 2 and minus 2, isn't it? If we looked at graphing that, I mean, we could also, so many ways of doing these, But m squared minus 4, that is m plus 2, m minus 2, isn't it, in factored form? So if we're factorizing, if we're sketching the graph, it's got intercepts at 2 and minus 2. So there we go. Now what are the values here? We're solving less than 0. Where is this quadratic less than 0? It's less than 0 here. So these are the values here. Looks like a big smiley face, doesn't it? This is, remember, this is the m axis. So the values of m that make this quadratic here less than 0 are between minus 2 and 2, not including, because at those values it's equal to 0. We don't want equal to 0, we want less than 0. And this is how we write the inequality, the solution. M is greater than minus 2 and less than 2. So that solves that. Okay, moving on. Actually, that might do for this screencast, and I'll make another screencast for graphing quadratics.